Hello everyone, my name is Ishwas Kumar. Today I am going to explain my third caption project, which is on credit card default prediction. Uh, it is a classification problem. It is done by team, by myself and my other teammate, who is Sabitendra Mahapratap. The project name is credit card default prediction. The project summary is it is a Taiwan-based data set which has the data set of customers with all the features. On payments of the previous data, uh, so we have to predict whether the customer will default or non-default based on the features they have given. It's a binary classification problem, so we have to use the models like logistic regression, KNNs, and decision trees classifier, random forest, etc. So this is my GitHub link. The problem statement I have explained now only. Uh, so let's begin the project. To know the to read our data, we have to import some libraries from the Python. Uh, so here are the some other libraries that has to be imported from Python to the Colab notebook. So we have to import, we have to feed the data path into the file path and create a data frame. The file which I have given is the Excel file. So it has the no column names included. So we have to use the header equal to 1 for the column names to be displayed. So here is the first view of our data set they have given, which includes the 25 columns, 25 features, 25 columns. In that, which is our dependent variable, default is or non-default. Here the data rows and column shape of the data frame. We have 3000 rows and 25 columns. Coming to the data set information. So data information, by using this method, we will get the whole idea about the data set. So here we can see the non-null object means 3000 rows will be present in each column, and they are on mainly integer types. Data.describe. So we have to check for the any duplicate values are there present. So by writing this code, we will get the duplicate value counts, which is 3000 means false. There is no duplicate values are present. And coming to missing values, as the info states that there is no non-values present or missing values present. We can use this function to count the null values in the each column. We can visualize this by this method. So what it's a shape of 3000 columns and 25 columns and 3000 rows. There are no missing values and duplicate values are present in the data set. So far, it's a complete clean data. So understanding our variables. So we have to easily examine and understand the variables they have provided to done the EDA analysis or feature engineering. The defaults columns will give the all the type of columns present in our data set. So these are the descriptions of the each and every column from our data set. ID represents the ID of the client. Balance limit represents the limit of the credit card balance. The gender is education master status, and these are the main things. Pay zero means repayment status in September. So zero ease of revolving credit means they are paid minimum only. Within the outstanding amount, they have paid minimum amount only, so which is not included the interest amount. So -1 means paid in full. -2 means no spending. They are not. One is for payment of delay months. So like this, we have data set present in our. So unique variables. We have write and function to check the count the unique variables from our data set. So to do the data wrangling or EDA part, for our analysis purpose, we have created a copy of the data frame. So each and every column is an integer type. They have given our label. So according to our analyzing purpose, we have renamed the columns as per our requirement, means for a easy case of understanding. So here I rename the column of default payment expense is defaulter or not. So I have replaced the renamed the column of page 0 as a repayment status September, like that, and bill amount is bill amount September. I have included a month's name in the column itself. So for the categorical columns means sex, one represent male, two represent female. Likewise for the education and marriage and is defaulter. Yes, mean one means yes, the customer is going to be defaulted. Zero means no, the customer is not going to be defaulted. So like that, I have replaced the values with the categorical variables. So after we are replacing the or renaming the columns, here is our final data set will be look like into the sex will be divided into the female like categorical column, and education, university, and like that. We can see the whole data set right here. So coming to the most important part of the data science or data analysis, the- here is the data visualization and storytelling, understanding the relationship between variables. For easy case of understanding for means to for the starters, so we have to they are know to how to kind of do the ADA part. So I've installed the pandas profiling, which is the cool library to do the EDA analysis quickly and to fastly understand the data, and what type of the analysis should we have to deal with. So by installing these panda profiling, so we can create the profile report from our data set, which is so we can output the same data file into the HTML file, which can be saved for further to analyze the things and to showcase our clients or the management. It's a cool library to use. So for that, I have implemented. But so coming to the dependent variables. First, we have to analyze the our dependent variable, which is default or non-default. From this chart, we can stately say that non-defaulted percentage is 77% and default percentage 22 percentage. So which is in case it is very large compared to our banking client program or client point of view, about banking view, financial view. So we have to reduce these numbers by correctly predicting the loyal customers or the right one customers. So coming to the second visualization of gender column, which is male and female, and the relationship between our dependent variable, that is defaulters. So we can see that the most of the customers are females only, means and 60% of the data we have are females, and 40% of the data we have females. And comparing the with the defaulters and non-defaulters, we have uh, equal number of means equal numbers of defaulters only, as comparing there is slightly a difference, and for the non-defaulters, female customers are likely to be having non-defaulting history. So in the business point of view, it is good to have the more number of female customers, uh, so as they are likely to be going to be the most case scenarios has been non-defaulters. So for this counting clear understanding of the numbers, I have created a used group by function to showcase the numbers. So in this female category, is default were as 3,600 three peoples are non-defaulters, and 14,349 are non-defaulters. So by ratio, we can say the females are the good customers, and means loyal customers or the easy early paying customers. So coming to the education column versus the defaulters, I can see that with the pie chart distribution of the education column, there are 46% of university graduates are there, and school graduates are there. Coming to the relationship between the with the dependent variable. Uh, we have we can see that university graduates have the highest non-defaults as well as the defaulters also. So here numbers can be shown that the university people have 3000 around 3000 people of defaulters, and the graduate school have 2000 people of non defaulters. So visualization of marriage column. uh, by pie chart, we can see the single person and married couples and the others. Uh, we can say that single person customers are more in our data set, and likewise the married customers are also equally follow the same amount of priority. And coming to the relationship with the defaulters or dependent variable, we can see that the married and single men's or single people have the equal number of the no defaulters. And coming to the numbers as stats say that in married we have these defaulters as 3000, and singles also we have 3000, so they distributely evenly distributed. So we can conclude that maximum cardholders are single and married people have higher default ratio, as we can conclude the results from these charts. Visualization of age column. So here is the some visualization of age column uh, of our credit card hold customers. So most of the our customers falls in between the 25 to 30 age. And coming to the defaulting criteria, so here we can say that the same number of age group, which is between 20 to 40, will have the highest so most of the credit hold belongs to 25 to 30 years. And also here we can conclude that the majority defaulters between the ages of 20 and 25 and over the 60. So which is good feature to look into that, as our bank customers will be mostly of these age group only, so they are like to be morely defaulted. Visualization of payment next month column. So here we can see that distribution of balance limit of credit card holder. So it is in e power 6, means it is varying from 10,000 to the 10 lakhs, like kind of thing. So most of the credit card holders which have a limit of around 10,000 to 5 lakhs distribution. So here we can see that 10,000 to 5 lakhs distribution. So here we can see that the defaulters are in the blue color, is defaulter S is in the blue color. So we can see the variation between the defaulters and non defaulters. So here in case that 50,000, there is a huge number of defaulters fall in that range. So equally with the highest limit. So we can conclude that with the when the credit card limit is over in between 5,000 to 10 lakhs, the non defaulting criteria is very less. So we can assure that the limit of the balance is around 5 lakhs to 10 lakhs. They are loyal customers, or the time being customer well paid customers. So here is monthly repayment status. So the monthly repayment status in June states that zero means they have paid minimum due. So what that is the status of the customers in the month of June. So they have the highest defaulters, means they paid only minimum amount of the bill. So they have left the interest. So they are like to be defaulted again in the next month. So they are like to be defaulted in the next month. So here we can see that the group using the group by function, we can see the numbers of the repayment status. So with these function, we can only see the number of defaulters with the S, means they are like to be. So in the August, so highest minimum, the who paid minimum due is the 2500, around 2500 numbers of the customers have been defaulted. So likewise, we can see the numbers here for every month. So bill amount is same, has between defaulters and non-defaulters. It follows the same distribution. There is no significant difference between the uh, from the plots. We can see the distribution of monthly bill has no thick difference between defaulter and non-defaulter. So pay amount versus bill amount. So I'm using the scatter plot here to see the distribution of between the pay amount and the bill amount. So when the previous amount is low but monthly bill payment is high, so there is a chance of defaulting will be there. So coming to the correlation heat map, which is the main factor of the ED analysis. By correlation map, we can see that the how the features are correlated with the dependent variable and correlated with the other variables. So we can see here that the yellow ones are the most correlated features with the dependent variable. So these are the bill amount. They have been mostly correlated with the same features, and here we can see that the repayment status September 0.67 is highly correlated with the repayment status of August. So the paying the amount. Okay. So we can state that the depending upon the previous amount status, means the payment status of the previous month, the next amount default will be based on the previous amount bills or the payments amount of the status. So these two are the highly correlated features within themselves. So we have to deal with the correlation as we are doing the feature engineering. So hypothesis testing, coming to the hypothesis testing, a married male defaults average age is 35 years. So I'm stating that the null, so default average age is the number of defaulter average age is 35 years, which is the married male category. So I'm using Z statistics test here to predict the p value or the so here I can conclude that the p value is less than 0.05. So the I can easily reject the null hypothesis and accept the alternate hypothesis. Sorry. Likewise, hypothesis test, null hypothesis mean. So the defaulters limit balance mean is around 90,000 or something. And the alternate hypothesis is not equal to 90,000. I am using the two tails test, which is the t statistics test. Here I can say from the results, I can say that it is less than the 0.05 probability. So I can reject the null hypothesis. Likewise, uh, the third hypothesis which I used is the defaulter does not depends on educational qualification. Defaulters also get affected by education qualification. So I can here I use the chi-square test, which is in type of classification problem. So I use the chi-square test to predict the hypothesis result. Here from the results, I can surely say that reject the null hypothesis and I can accept the alternate hypothesis. So coming to the feature engineering and data pre-processing. So handling missing values, as I mentioned earlier, there is no missing values or the or null type of data we present in the our data frame. So there is no need to be done the missing value treatment or something. On duplicate values also, there is no duplicate values are present in the It is the more handling outliers. Outliers treatment should be done so that our model should be trained well and no overfitting should be there. So from the figure, we can see that outliers using the box plot. We can see the outliers present in the data frame. For outlier the outlier treatment, we can use the IQR method, which is interquartile range method. So categorical encoding. In before we have created some categorical features to analyze in the columns in our expiry data analysis. Now we have to replace the categorical features into the integer features to feed our data into the model. So we are replacing defaulter s with 1 and no with 0, and we have to get it dummies for each and every column. Like here we can see that the each and every column has been repeated with a dummy variable. There is no textual data present in the data set, so we don't need to consider the textual data pre-processing. There is no features to be manipulated. Coming to the feature selection, which is the most important features of the model implementation or the model selection process. So here I choose the chi-square test to predict the important features to be selected. Uh, so by chi-square test, which has the highest chi-square score, will be the most reliable feature to predict the dependent variable. From these chi-square test or function, we have concluded that the repayment status of the each and month have the highest scores to which are mainly to be having giving the highest most important features to predict the dependent variables. And another test should be implemented as a with the Gini gain or information gain. We can see that the both with the both methods we uh, have the same feature importance. So everything in our data frame is normally distributed. So we don't need to be change the dimensionality. We don't need to change the do the data transformation. So handling imbalanced data set, we can see that the 70% of the data which has the non-defaulters column. So our data is highly imbalanced. So for that, we need to do the balancing of the data frame. So which I use the smooth technique to balance our data set. So here we can see that the after before the balancing, we can see that the zeros or the two one means the defaulters will be only 6,000. After doing the balancing, we can see that the equal number of the defaulters values are present in the data set. So data splitting, here is the to train the model, we have to split the data into two parts, which is train and test. In this case, I have used the test size of 0.25, which is 75% of the data will be used to train the data, and the 25% will be used for testing the data. So data scaling, for all the features to be equally scaled, I use the standard scaler uh, to scale our data. So here is the one cool statistics test, that is the KS statistics state to predict our model how our performance of the model will be. So means how good our model is in determining the two variables, that is in between the good and bad. We can use the KS table or the KS statistic test to view the our performance of the model. In this case table, I am the data frame which is equally divided into the 10 beans with 10 buckets. So each bucket consists of 100 number of data set. In the data set, we will be testing with the minimum probability and maximum probability. Here we can see that the minimum probability, maximum probability, and the target variable, which is the 0, 1. So and the non events will be the 1 and non events will be the 0. So with the equal probability and probability, we can calculate the event rate and non-event rate, and cumulative event rate and cumulative non-event rate. So here is the whole table. You can form case table. Coming to the model implementation, first we will use the logistic regression for the classification problem. Now we can import the logistic regression model from the scikit-learn dot model. So here we can fitting the model using the logistic regression. So here we can see that the coefficient obtained from the logistic mean for each and every one feature. With the highest feature, the 63, we can see the best features from the logistic regression. So this is the KS table which I mentioned before earlier. So the data frame is equally distributed into 10 equal buckets with the minimum probability and maximum probability, and with the events. Events means the customer is going to be the default, means yes, means 1. Non-events means 0. So event rate is calculated with the 3505, the total number of the events. So it is the 20%, and non-event percent is 0. So from the case table, we can see that the how from where it can start segregating the data from the events to the non-events. So here we can see that the data or model is starting predicting from the fourth bucket, means with the 70.1% case score. So case statistic score. So we can say that the minimum probability is this and maximum probability is 0.955. So we can say that with the probability, means which is the probability greater than 4 and less than 0.99 are likely to be more defaulted in our case. So these are for evaluating the our model metric score chart. We are using the accuracy, precision, recall, F1 score, and AUC ROC curve. Among these, recall is the most suited for our classification problem, as because we don't want to lose the financial loss of predicting the defaulted customers as non-defaulter. This will encourage to the huge financial loss to the bank or organization. So the recall will correctly predict the true positive within the with lowering the false negatives. So means false negative will be low as the recall will be growing, means they're inversely proportional. So with the highest score of recall, we can say that our false negative means or our false predictions will be less. And another library which is scikit-plot, which is used to draw the confusion matrix and the case statistic AOC ROC curve. So in logistic regression, in the training set prediction, we can see that the non-defaulters and defaulters as the 0, 1. So this is 0 and this is 1. So we can see that the true positive, the recall score will be true positive plus this is the true positive, means the model is predicting 1 as 1. So true positive by true positive plus false negative. So false negative means this one. So uh, uh, this one. So true positive plus false negative will be the recall score. We can see the ROC curve. We can see that the within the threshold of 0.439, the model is start to segregating in our data set, and which is the highest distance between the defaulter curve and the non-defaulter defaulting curve. So using cross validation and hyperparameter metering, we can optimize the logistic regression model. So this is the code to implement the grid search CV. I use the grid search CV to uh, implement hyper tune the my model logistic regression. So by doing that, I can get then I got the best parameters as 0.001 and penalty as a L2 regression. So with these parameters, uh, further I will be tuning the logistic regression model furthermore. So by tuning the logistic regression by using the KS table, I got 68.7% at decile 4. So it is starting to segregate or to differentiate between the goods and the bads from the fourth bucket with a KS score of 68, 0.68. And this is the confusion matrix. And this is the ROC curve, and the KS statistic score will be given there. So I'm writing the code to implement each and every score of our model in a data frame. So this is the definition of the function metric score, which will be used to store our model score in a data frame. So we can see that after tuning our data frame, there is a recall has an improvement of 0.1. The accuracy is the same. So pretty much same. The KS statistic score is also pretty much same. So there is slightly improvement of doing the hypermetric tuning. So second model I implemented is decision tree classifier. So I use the decision classifier with the criterion of a Gini, which is segregating uh, uh, the binary for the using Gini is used for the binary classification. I've fitted a model using a decision tree. So here, by implementing the decision tree, I can see the confusion metric and the KS statistic plot, which is 70% with the KS score. It is starting to segregate from the fifth bin or fourth bin, I think. This is the trained data KS statistic plot, and this is the test data KS statistic plot, which is pretty good. So after doing the cross validation, I managed to predict the best parameter to do the hyperparameter optimization. I've used the decision classifier and parameter grid maximum depth as the 5, 20, 25, 30, 35, 40, and maximum minimum sample split and minimum sample sleeve. By using the optimization technique and using the grid search CV, I got the best parameters as maximum depth equal to 20, minimum samples equal to 40, and minimum sample splits equal to 50. With this score, I have trained my model again, and I got the confusion metrics of training set and confusion metrics of tested prediction. So this is the KS plot of training data set, and this is the KS plot of testing test data set. So we cannot do the KS table thing right with this decision tree classifier, because it is probably predicting the probability of predicting the ones as 1 and zeros as 0. So we cannot get the minimum probability and maximum probability like in the previous case. So here we can see the difference between the each probability and each bucket bin, but there is no probability difference between the in the decision tree classifier. So it cannot distribute the data into 10 equal buckets. That is the error I got in doing this, implementing that KS table thing. The third classifier I used is random forest classifier with the estimations of 100 and criteria is equal to entropy. Entropy is the disorderness, means predicting the disorderness of between the data frame means. So with this implementation, I got the recall score. K statistic is 99%, starting from the fourth bin, which is the good score actually. And we can see that the true negative is very low in the training data set, means 6 is there, true positives are there. Is also yeah, defaulter and defaulter. The model has correctly predicted the maximum number of values with this model. Again, I have further optimized the random forest model using the grid search CV to draw the best parameters that can be implemented in implementing the random forest model. By implementing the grid search CV, I got the maximum depth as and minimum sample if is 1 and minimum sample if is 2 and number of estimators will be 250. So with these estimators, I furthermore implemented the fitted the training data into the uh, best random forest algorithm. So furthermore get the confusion metrics. So the numbers have been decreased in the training data set well as so the model has been improved slightly. We can see the KS table for the random forest model. So we have KS statistic of 99.97%, means from the fifth bin onwards, it is starting to segregate the 100% of the data from the good ones to the bad ones, means the model has been performed very well. So from the fifth bin, we can see that the minimum probability of the model should be 0.33. So, and the maximum probability will be 0.48. 0.848. Within these threshold, we can say that the customers will have more chance of going to be defaulters. Metric score, we can see that the recall score has been improved in the tuned. This is the random forest classifier RF. The recall is the same. So we can see the highest recall score has been got from the true random forest classifier, that is optimized the random forest classifier. So the case nearest neighborhood, which is the pretty good classifier to implement to classify the binary the credit card default prediction. So in the K nearest neighbors, it is the training time is 0 in this case, which is actually we are not going to train or the model. It is actually predicting the values with the data within the data itself. So there is only testing time. So based on the nearest neighbors, uh, it will classify that it will default or non-default. So by visualizing, we can see the confusion matrix and the numbers of default predicting the positive as positive and the negatives are negative. The K status score is 0.753. So again, we have optimized the KNN algorithm to get the best parameters out of using the grid search CV. Using the grid search CV, we have implemented get the number of neighbors should be 3 and the p-value should be weights equal to distance, means the distance is the parametric curve, means in the it will calculate the distance with the every point in the data set and calculate the uh, decides the result, means probability of getting result as a defaulting or non-default. We can see the accuracy score, a recall score of 0.79, which is less than the random forest classifier. Next is the ADA boost classifier, which is the assembling method I used to Uh, the use number of estimators has 100. I've implemented the fitted the model within the train and test data. So I got the confusion matrix with these values. You can clearly see the case statistics test means uh, it is not able to separate between the good and bad. So it is being the plot is being closely enclosed. So I've furthermore tuned the model to get the best parameters using grid search CV. By using grid search CV, I learned the best parameters as learning rate equal to 1, that is alpha value, and number of estimators is equal to 50. With those best parameters, I have furthermore fit the data into the best using best parameters. So with the hyperconductance, this is going to be slightly improved, and we can see the slightly difference between the zeros and the one class, which is defaulters and non-defaulters. So by using the case table, we can see that uh, the case statistic score is 70.6% if we decide 4. So we can see the recall score of the Adabus classifier as 0.77, which is less than the still less than the random forest. This is the tuned Adabus recall score, which is 0.78. There is 0.1% increment in the recall score. The final model which you implemented is the XGBoost. That is the gradient boosting method, which is used to classify the from uh, is to classify the uh, defaulters and non-defaulters. With this model implementation, I got the confusion matrix uh, and the case statistic lost, which is RUC and AC curve, which is pretty much uh, is going to be separable from the with the 0.48 case statistic score from the fourth decile or the fourth bin. I have been furthermore tuned our model using the grid search CV to estimate the best parameters. So with the grid search CV, I have got the best parameters as maximum is equal to 9 and number of estimators equal to 150. And I have trained the model with these best parameters. Then I got the conversion metrics, and I have furthermore implemented the case statistic plot, which is uh, pretty good on the training data set with the case statistic percentage of 0.498989 at from the fourth decile, which is also implemented on the training data set, which is pretty good improvement from the previous one, which is the normal XGBoost compared to the tuned XGBoost. So from the case table, you can see that the 84 it is starting to differentiate between the goods defaulters and non-defaulters from the bucket with the case score of 84.5%. And the tuned or optimized XGBoost classifier is pretty much good with the 98.8% from the decile 5, which is from the fifth bucket. It is uh, and one more thing, this case table is based on the training data set. So from these 10 all models, we can clearly see the scores of each model, accuracy, precision, recall, FM score. In that, recall is the best parameter to check the model performance and the model score. Among these models, the random forest has the highest recall score, which is 0.4738. So that I am going to implement in the I'm going to select these model as my final model to correctly predict the defaulting persons. And one more thing, I've implemented Lime to local interval model agnostic explanation to determine which parameters have been causing the uh, customer to draw into the defaulter section and non-defaulter section. For that, I have included Lime package. I imported Lime package from the Python, and j equal to 5, which is the fifth column or the value, fifth row of the data. It will take the fifth row of that test x test column, means the text data frame, and predict the outcome of the that using that features, and gives the complete detailed report that how which parameter is contributing to the final result. Here we can see that the fifth customer or the fifth data we have coming to be non-defaulter. So for to state that these are the reasons, means these are the most features that are contributing the uh, customer to finally determine that he is non-defaulter. The blue ones, which are more likely to be the education, and the blue ones are the more contributing to the non-defaulters, and the orange ones are contributing to the defaulters thing. So we can see that by visualizing that how which features are doing contributing to predict the defaults or non-defaulters. So I've invented sharp technique to showcase the best features, but conclusion, we saw that our data had uneven class, means we have the imbalanced data set with the 70% of the non-defaulters in the cover case. So we have balanced the data set using the smooth technique, and the majority of credit card female. Okay, the credit card holders are female. In our positive business impact, we can encourage, we can give the more number of female customers, so they are more likely repaid, or their percentage of means coming to the default is very less. So highly educated people are less likely to default. We can see that university graduates are more in our case. So the well educated people are more likely to be less likely to be default, and fewer educated people are more likely to default. So the education part is going to be major role in the determining the defaulter or non-defaulter. Uh, So in this scenario, recall is the significant parameter to compare all of the algorithms, because the corporation cannot afford to anticipate a false negative, means we cannot lose the you cannot wrongly predict the default customer as non-default, because it can be uh, it can be huge loss to the organization. So we can consider the recall as our parametric metric score to compare the performance of the model. So in among these implemented models, the random correct classifier as the model has a high recall of 83%. So I will not use any case my best model. So KNN is as mentioned is the nearest neighbor. So it predicts the outcome based on the nearest neighbors, means the surrounding feature data points in the data set. So it is more likely to be used for the R&D problems, or the mechanical elements, the design problems which have the low data set, and we cannot use this in this financial risk analysis. So will not use the KNN. This is my whole project on the capstone of credit card fraud default detection using the classification algorithms. Uh, Thank you.